on Friday, or just like figuring out which quadrant the triangle is in. Unfortunately, every single one of these questions, or in every single one of them, they were all quadrant 3, hey? If you guys didn't forget that. It's a bit irritating. Sorry, I didn't realize that when I gave. It's not always going to be in quadrant 3, guys. You are late everything, sir. And everyone else is on time.
These are all before the top.
Oh,
Nothing.
Everyone, I got all of them in 3 years. Which one? I'll check. Maybe I'll do them. Now, okay. I'll be fine with that, figuring out which quadrant it is in first. So you take the 4 across, you have the figure 4, and then you divide by 5. So where is sign negative in quadrant 3 and 4, and where is cos positive in quadrant 1 and 3. What did I write 2 and 3? 1 and 3, eh? Not also good start. Maybe I did use the wrong quadrants. Okay, quadrant 1 and 3. Here we go. So the quadrant that satisfies both of those is quadrant 3. All right, so then you draw your triangle. Your theta is going to be that whole angle. You can make sure that you are indicating it properly. So it's from the x-axis from your 0 line going to be all the way around to that line there. Because it's sine, that means that it's opposite over hypotenuse. So the opposite one has to be negative, the hypotenuse is going to be 5. Okay. What was I doing? I was doing negative instead of positive. So that's then actually quadrant 4. Yes. Okay. Let's mark number 1 later. Okay, number 2. Sorry about that. I was doing negative. Thank you, Safra. Okay, the second time is correct. Number 2. Tan positive 1 and 3. Get it? That's correct. ASTCX. Quadrant 1 and 3. And then they said theta, they just put X in the book, I think, but it's the typo. Theta has to be between 90 and 270. So the 99 is over there. And the 279 is there. So that's quadrant 2 over there. So that one has to be okay, because 3 is the one that has to find both of those. Now, guys, the tricky thing here is that it was positive 12 over 5. But if you're looking at where the triangle is, this is actually a negative 12. Yeah, because it's on the negative side of the y-axis. And this x also actually is negative, because it's on the negative side of the x-axis. And guys, that will still give us a positive answer, right? Because what's negative 12 divided by negative 5? Negative divided by negative is still a positive. Okay, so just be aware of that. That was like a tricky thing about this question, is that you have to put a minus, thank you, for both of them. Just because it is in the third quadrant that it works out like that. Okay, so just check. If you just put a 12 and a 5, then your final answer here is not going to be. Okay, then you use that to find your hypotenuse, 13. Guys, remember I said the other day, you don't have to put a negative and a negative here. You can just work with 12 and 5, that's fine. So if you wrote it like this, h squared is 12 squared plus 5 squared. That's fine, so you're just working with the length to get the same answer anyway. Now, I don't know if you guys noticed this, but to remember when you're working with fractions, if you have the same denominator, you can just subtract them, right? So 10 over cos theta minus 5 over cos theta, you actually could have just said 10 minus 5. It's 5 over cos theta. Why if you didn't notice that, if you actually work them out separately, it just would have been a bit more calculation that you have. So if you did it like this, if you say 10 over negative 12 over 13 minus 5 over negative 12 over 13. And guys, the unfortunate thing about these questions is because it says without a calculator, you can't just go straight from this to your answer. Right? You actually literally have to do it without using a calculator. So you would have to do like a different times for both of them and subtract. Okay. So here you would say 10 times, do we remember, instead of dividing by a fraction, we can actually just step them times. So the 12 over 13, I'm changing to 13 over 12, and then you would minus the brackets around this. So you see, it's quite a complicated calculation if you just notice that, oh, they have the same denominator, that's just minus. So then you would have 5 times negative 13 over 12. Did I do that wrong? No! What is happening? Guys, what are you doing? When was I doing this? I thought I was watching something while I was doing it. Okay? Yes. I don't know, that's what I was talking about. That's what I was talking about, the stuff correctly. Okay. So, oh no, it's been a rough couple of days. Okay, wait, let me just check here. So this is supposed to be 5. Nice. Terrible. Negative 5, and then that's supposed to be a 5, and then this is negative 13. Okay, that's a nice answer. Negative 13. Sure, terrible. Okay, and this one, 5 and 5 and 5. Okay, 5, sorry, I'm almost there. And 5 and 5 and 5. Okay, so that actually gives us a nice answer actually. So now here the 5s are gonna, well, that 5 is gonna cancel out there, and I'm gonna be left with 3, right? And here the 5s are gonna cancel out. So that will leave me with 2 times negative 13, which is negative 26. Minus negative 13, which is going to give me plus 13. And then we get negative 13. And I'm worried about the rest of it. Let's get the actual textbook with me. What page was this again? Okay, so for the next one, they said 7 times theta is 3 and cos is positive. I did cos negative. No, guys. Surely I was joking here. Okay, this one, number 4. I'm gonna have to redo any question. Number 4 is this one. Cos is negative. That is yes. Cos is negative then. Cos is a negative 3, right? And we divide by 5. So cos is negative and cos is positive. Yes. And then here between 180 and 360, 3 and 4. Yeah, I think this one at least is my last one. Sorry guys, I'll just read through those others that I'm just okay, I'll try and come back. So this is quite similar to the first one where you must first take the 3 over and remember to make it negative 3 and then you divide by 5. So now where it cos negative and cos 2 and 3. And this, where they said, let me just check that I copied that correctly. Yes, x was now be between 180 and 360. So if you're looking at your Cartesian plane, right? Remember that's 0, 90, 180, 270, and then 360 there at 0 as well. So they were talking about between 180 and 360 is going to be positive 3. Okay, so then I underlined the one that satisfies both conditions, so that was positive 3. And then let's just see cos. Remember, cos is adjacent over hypotenuse. So those are the 2 lengths that they gave us. So you put your angle in here, which was angle x this time, not theta. So now the adjacent side is going to be negative 3. That's the one that's next to it is negative 3. And the hypotenuse is going to be 5. So then from there, I use pi times. You can see there. Now remember, this side that we're finding here is not the hypotenuse. So we can't add those 2 that we have together. You have to say hypotenuse squared minus the other one squared. Remember to write pi guys if you use it. So guys, the length of y is 4 units, but remember you have to check which quadrant it's in, right? Because it was in quadrant 3, it has to be -4. Do you understand why that is, guys? And this is very different if you're not sure. It's because it's on the negative side of the y-axis, right? Y is 0 there, positive y values up there, negative y values. Yeah, okay, so y is 4 units, yes, but because it's in quadrant 3, the actual value of y has to be like yes. So there is a mark for getting it in the right quadrant, and then everything follows on from there. So you might use 1 or 2, then after that, we'll see. Yeah, so it also kind of depends on who's marking. So I would just make you lose one because I would just say that one mistake. By drawing it in the wrong quadrant. But some teachers then say that you must also lose the mark for, because say you drew it in quadrant 2, right? When it was supposed to be here. Then you are supposed to be getting, if your sign was here, you'll get positive, where it's supposed to be negative. Some teachers will take that mark off for the positive. Okay. Yes, but not for exact. Okay, so now when you have your -4, they were asking us for this 3 tan x plus 25 sine squared x. So just check there, please. Did anyone else get going to do that one? Okay, thank you. So 3 times tan x, remember tan is opposite over there. So the -4 that we calculated over the -3 that we had, which is just 4 over 3. And then for sine squared x, guys, that's just sine x that we squared. Okay, so I'm just going to show you on the picture quickly. Sine, if this is our x angle, sine is -4 opposite over hypotenuse 5. And then you square that. Remember guys, here in terms of like bond maths, you have to square before you multiply the 25. Okay, so first you have to say what's -4 squared and 5 squared is 25. And then you can cancel out those 25. Right? For this one at the top, the 3's are going to cancel out. So you have -4 over -1, which is just 4. And then plus 16. Good, that's just it. We always hold it because it's like a. What else can we call them? Diagram problems. I don't know. What is it? These questions, right? These triangles. Okay, so guys, which ones do I have to fix? 1 and 3. Hey. Okay, I'll do those and we can mark them tomorrow. I'm wasting time. Okay, proving identities. That is the next heading, please. It's something new, it's something you didn't do last year, something completely new. So proving identities like that. Hmm? Okay, now guys, identity, that's also not a term that you've actually heard before, that you've worked with before. An identity is basically like a formula that's always true. So I'm just going to write that here. Now, in grade 11, there are two identities that you have to know off by heart and that you need to be able to use. And it's almost like working with Python, right? It's a formula that we use in certain conditions. It's a similar type of thing. So the first one that I'm going to write down is that sine squared x plus cos squared x is always equal to 1. That that is the case. If you take sine squared of an angle plus cos squared of that same angle, it will actually always be equal to 1. So if we do, now remember when you want to do a sine squared or a cos squared on the calculator, you actually have to do sine of the angle in brackets and then guys remember that from last year. So there is no sine squared button. Alright, so if you want to do like sine squared 30, you'll have to say sine 30, close bracket, and I have to close it twice, right? Because it's a bracket, you close the 30 and then another one, and then you square. Okay, that's the same as sine squared 30 plus cos 30 squared, and then we see that as 1. Alright, now I'm just going to change. I wonder if I'm going to change this angle. See. Yes. Let's do sine of 100 squared. And then I'm just going to change the other one to 100 as well. And that was squared, yes. And then the answer is 1. Alright, sine of 1 more. Let's do a negative angle because we can do that as well. Negative 45 squared plus cos the same angle, negative 45 squared, and then the answer is also 1. Alright guys, so that is something that happens all the time. If you take sine squared of an angle plus cos squared of that same angle, that's important. It has to be the same two angles, otherwise it's not going to work. Then the answer is equal to 1. Now guys, we are usually not going to use it with numbers like I showed you now. We're usually going to use this as like a formula that we're going to sub in. Okay, I'll show you this example. Now guys, this formula we can use in different ways as well. I can find a formula for just sine squared x by using this formula. Okay, so I'm going to use a then arrow because this next formula is coming from this identity. If I make sine squared x the subject, meaning I'm going to move that cos squared x over to the other side. What did I already have on the other side? The 1. And if I move it past cos squared x, it's going to become minus cos squared x. So this is going to be 1 minus cos squared x. That is like an extra formula that we're getting from that identity. So you'll see when we're doing examples, sometimes it's useful that if you have a sine squared x, to actually replace it with 1 minus cos squared. Okay, we can do the same thing with cos squared x. We can make cos squared x a subject. So I'm working from this formula, right? If I want to make cos squared x a subject, I need to move this sine squared x over. It's going to become minus. So I'll have 1 minus sine squared x. So again, sometimes in an identity, the questions that will come later, it might be useful that if you have a cos squared x there, to change it to 1 minus sine squared. Okay, so that's the first identity. The second one is that tan x, you might have actually been using it, possibly, is sine x over cos x. So guys, how does actually work? Sine, how do I find sine again? What's the formula for sine? Just sine, yeah, opposite over hypotenuse, right? So opposite over hypotenuse, thank you. And cos is adjacent over hypotenuse, right? So now instead of dividing by a fraction, I can tip it times, yes? So instead of dividing by a over h, I can change that to timesing by h over a. You see what happens with those h's? They're going to cancel out. What's left? Opposite over adjacent. And isn't that the formula for tan? Right, tan is opposite over adjacent. Okay, so that is where that one actually comes from. But if you have a side with the opposite over hypotenuse and you divide it by cos, which is adjacent over hypotenuse, that will actually simplify to opposite over adjacent, which is tan. So guys, you see now the questions that we're going to do. Often if you have a tan x, change the sign of the cos immediately. Now the thing with this identity is that all three of these angles have to be the same. All right, it doesn't have to be an x, it can be like a 2x. So for example, if you have tan 2x, you can change that to sine 2x or cos 2. But whatever the angle for x is, that is going to be the angle of your sine and cos. All right, so these angles have to be the same always. You can't have like a tan 2x and then change that to sine x over cos x. All right, it has to be the same angle. So I'll just write another example here. So if you have like tan 2x, you'll have to change that to sine 2x over cos 2x. Another thing is that this formula also works, or this identity rather, also works for squares. So if you have tan squared x, you can also change that to sine squared x, yes, over cos squared. And then just a third and final, like different way of using this formula is sometimes in a question you'll see they'll give you cos over sine instead of sine over cos. If you have a sine, and this works both ways, right guys? So if in a question they've given you sine x over cos x, you can also change it to tan x. Okay, these formulas can go both ways. But now what if they swap these two around? So that instead of sine x over cos x, they have cos x over sine x. Yes, because 1 over tan x. So cos x over sine x is the reciprocal of this one, right? We can swap them around. And this is tan x over 1. So that will give you 1 over tan x. Just in case. It doesn't come up often, but just in case. So basically you're swapping both sides of the identity around. Okay, we are going to get into some examples. And like I said, guys, we didn't do anything like this last year, so maybe at first we're going to be at the confused. But yeah, we're going to see how many examples we can get through today. Guys, when you see a equation like this where it says that you must prove an identity, what you're going to do is you're not going to treat this as if it's an equation, right? When we're working with an equation, you can move stuff across the equal sign, change the plus to a minus, whatever. Okay. This is not an equation, guys. You're not solving for x. You're not solving for sin x or cos x or tan x or anything. It doesn't say at any point solve. Okay, it says that we must prove. So what they want us to do is we have to show that what we have on the left-hand side is in fact equal to what we have on the right-hand side. So what we're going to do, guys, we're going to start by working on the left, do all sorts of things, and change it into 1 minus cos squared. Okay, so when it says prove, we're going to change the left-hand side to the right-hand side. Because if you can do that, if you can change sin x times cos x times tan x to 1 minus cos squared x, then you have proven that this is true. Okay, then you have actually shown that the left-hand side is equal to the right-hand side. It has to have a specific layout, guys. If you are working on both sides at the same time, so if you're treating it as if it's an equation, if you're moving, for example, say you decide, oh, I want to divide by cos x on that side, so I'm going to move it across. If you do that, you get 0 straight away. Okay, you have to. For proving identities, you have to work on the left-hand side only and change it to the right-hand side. Okay, or work on the right-hand side, change it to the left-hand side. You have to work with one side and change it to the other side. So what we're going to do is you have to start out by saying LHS, which means left-hand side. You can write LHS, that's fine. Get full marks for that. What I'm going to do is I'm actually just going to rewrite the left-hand side. You don't really have to, but I just want us to be sure of what we're actually working with here. We are working with sin x times cos x times tan x. I'm not touching the 1 minus cos squared x on the other side. I'm not going to do anything with that. What I want to do now, guys, is I want to change this expression. Do various things to it so that it becomes 1 minus cos squared. Does anyone have an idea? What can I do? Now we need to use these identities that we've written down here. We need to change whatever we have on our left-hand side according or using these identities. So what do you think, guys? What about that tan? What can I change tan x to? Tan x is the same as sin x over cos x. So that's what I'm going to do, guys. I'm going to say this is equal to sin x times cos x times sin x over cos x. That will get you your first mark. So that if you get one of these and you don't know what to do, but you see that there's a tan somewhere, change it to sin over cos. Okay, 99% of the time that will be good. We need to keep working on this, guys. We need to do something there so that I can change it to 1 minus cos squared x. So what do you guys think? Just notice that I'm multiplying this all together. Hey, there's no pluses or minuses. It's all one term. What do we think? Have a cos x in that denominator now. Is there a cos x in the numerator that can cancel it out? Okay, these two cos x's can cancel each other out, right? Now guys, if you draw the line like that, make sure that it's quite faint so that I can still see what you wrote there first. Okay, so when I do that, what's going to be left? Sin x times sin x, which is sin squared x. Remember, guys, what about trying to change this into 1 minus cos squared x? Sin squared x is 1 minus cos squared x. Okay, using that identity, we wrote it up there. So sin squared x, you can change to 1 minus cos squared x. So that is then just your last step. This is 1 minus cos squared x. You have to write this down, guys. You can't just say, oh, I know in my head that it's equal. Then you have to write that down. And now as our final step equals right hand side. Okay, you just always have to round it off like that. So that the left-hand side is equal to the right-hand side. Okay, so you're getting kind of an idea of what we need to do here. Yeah. So this one wouldn't be that many. It would be 1 mark for that, 1 mark for getting to this. So basically cancelling out and timesing. And then, you know, a mark for applying that again. Yes. The questions that you will end up getting in a paper exam if you here on part. They can get more complicated. Yeah. Okay, so let's do another one, guys. Number 2. So we have cos cubed x, plus cos x times sine squared x, and that should be equal to cos x. So what I want you to notice is that on the left-hand side, how many terms do I have? 2, okay? I have multiple terms. So it doesn't really matter how many, but we all see that we have multiple terms here. On the right-hand side, the one that I'm trying to get to, do we see that that's just one term? Right? No, this is just one term. So here, I'm just going to write a little note. We have multiple terms that we need to try and turn into one term. Guys, what do we use in order to go from multiple terms to just one term? Factorizing, good. So we are going to have to factorize on the left-hand side. Guys, unfortunately, I don't know how you guys feel about factorizing. It does come up in this section quite a lot. Okay, where you have to factorize. Either by taking out a common factor, maybe doing a difference of two squares, possibly even trinomials, which is quite tricky. Okay, but we'll get to that. So something to keep in mind definitely is maybe you're gonna have to factorize. Especially if you see this, you have multiple terms, and now somehow you need to go to one term, all right? In that case, you will always have to factorize. Okay, so let's write here LHS. Again, I'm just going to write down what is on the left-hand side so that I'm absolutely certain of what I am working with. With those two terms, and I need to get it to cos x. So guys, like we already said, we're going to have to factorize. So now what type of factorizing do you see there? What can I do? The first type that we check for is common factor, right? Is there a common factor there? Cos cubed x, and then a cos x sine squared x. Cos x, yeah. Is that what you're going to say? Yeah. Cos x is a common factor because, guys, what's cos cubed x? Cos x times cos x times cos x, right? So cos x is definitely a common factor here. And remember, when we take our common factor, we have to divide what we had at first by that common factor. So cos cubed x divided by cos x, what do you think that's going to be? Cos squared x. Good. It's like x cubed divided by x is x squared. Okay, just now cos x. And for the next term, if I have cos x times sine squared x, and I divide by cos x, what's going to be left? Just sine squared x, hey? So cos squared x plus sine squared x. Okay, so now we do have one term, right? Because we have cos x times the bracket, that's one term. But we actually just want cos x, right? So what can I do here? Yes, well, so I could, but even faster, cos squared plus sine squared. is the same as here. It's the same as sine squared plus cos squared. The order is just different, but it's fine, right? 1 plus 2 is 3. 2 plus 1 is also 3. Okay. So these two, sine squared x plus cos squared x is the same as cos squared x plus sine squared x. So I'm going to use this identity here. That bracket is actually just equal to 1. Okay, cos squared plus sine squared is just 1. Now guys, to make it absolutely clear to the marker, to me, that you are using that, please put 1 in a bracket. It does seem a bit silly, but you'll actually get a mark for that. Okay, for showing that cos squared plus sine squared is 1. So what's cos x times 1? Cos x, eh? Which is the right-hand side. There we go. Okay. Any questions on this one, guys? We'll do another one. Number 3. So we have sine to the power of 4x minus cos to the power of 4x, and that should be equal to 1 minus 2 cos squared. Okay, now guys, in this case, we don't have multiple terms going to one term, right? We have multiple terms going to multiple terms again. But yeah, we have to try and do something then. What do you guys think? Does anyone have an idea? I'm going to start on the left-hand side again. So I will write that down so long. If we stick to the theme of factorizing. Difference of two squares, hey, good. That is the difference of two squares, yes. Do we remember what do you do when you factorize the difference of two squares? You end up with two brackets. And in those brackets, you're going to put the square roots of the two terms, right? I don't know if my brackets are big enough. But the square root of sine to the power of 4x. What's that going to be? Sine squared x, yes, good. So that, I'm going to have to move my brackets a bit. So that is going to go in both brackets, sine squared x and sine squared x, thank you. In the one bracket, you put a plus, in the other bracket, a minus, right? And what is the square root of cos to the 4x? Cos squared x. So that is also going to go in both brackets. Just going to write here on the side next to this that this was a difference of two squares. Maybe just add that because you might forget that when you want to look back at this example. Guys, difference of two squares is actually used very often in this section. Okay, so that is definitely something to be on the lookout for. Okay, now we want to get to 1 minus 2 cos squared. Okay, we're not quite there yet. What else do you guys notice? That first bracket again is 1. Hey, sine squared x plus cos squared x is 1. Okay, so I'm just going to change that to 1 in the next step. And I'm still going to have my sine squared x minus cos squared x. Again, guys, I know it seems a bit silly to put that 1 in brackets, but you do get a mark for doing that. Because it's showing the marker that you remember that identity. You add it. All right, but 1 times that bracket is just going to be sine squared x minus cos squared. About what am I trying to get to? 1 minus 2 cos squared x. Okay, so what I have at the moment has a sign in it, but what I'm trying to get to doesn't have a sign in it. So basically, I'm going to have to change this sine squared x to something else. Because I don't want sine squared on the right. 1 minus cos squared x. Yes, so sine squared x, I'm going to change to 1 minus cos squared x. Minus, yes, there was already a minus cos squared x, so I must remember to write that down. I'm just going to highlight these parts, guys. This sine squared x here is 1 minus cos squared. Okay, so I didn't put like an extra cos squared x there. I changed sine squared x to 1 minus cos squared x, and there was already a minus cos squared. Okay, so there we have that 1. Now, guys, what do you think negative cos squared x minus another cos squared x is going to be? Negative 2 cos squared x. Good, and that's what we wanted, hey? That is what was on the right-hand side. So guys, I just need to mention one thing that I didn't actually mention when we wrote down the identities. If we're looking at this first one, this only works when you have squares. Okay, so maybe you just want to highlight those squares there. And here as well in the other version of those identities, or that identity. So you can't say, guys, that sine x is 1 minus cos x. It doesn't work. Okay, they have to be squared. That's very important for you for that first identity. So it has to be sine squared plus cos squared to equal 1. And here, because this is a mistake that people often make, they think, okay, sine x, it says sine squared x is 1 minus cos squared x. So a lot of people want to change sine x in order squared to 1 minus cos x. Okay, but that's actually wrong. You can't do that. Okay, so in order to use this first identity, they have to be squared. Okay, or they can be like to the power of 4, for example, but it can't just be like this with the sine and cos. Okay, guys, I'm going to give you a few of these to practice. The thing with these questions, they are quite difficult to start working on because it's almost like there's so much that you must think of, right? So in this one example that we did 3 different methods. In the first one, we just changed tan to sine over cos, and then we had to use that other identity. Okay, that worked for us. In the second one, we had to factorize by taking out a common factor, and then we applied an identity. In the third one, we had to factorize the difference of 2 squares, and then we applied this identity to make that 1, and we applied a different identity to make that equal to 1 minus cos squared. So guys, it's not always, unfortunately, going to be like the first one, where you can just use an identity and use an identity and you're done. Okay, you're usually going to have to do some kind of factorizing, or you'll see now in the first one that I'm going to give you. I'll write it down for you. Let's just write here, the homework is exercise 5. Guys, I know the stuff is in your text, so basically doing this homework is like studying for the test, so please, you're gonna have to. Page 144. I would like you to do numbers 3 and 5. I'm gonna give you hints just on how to get started. Right. And 12. I'm going to write the questions down for you here, guys, so that I can just make a little note next to each of them. Okay, so that is the first one, guys. Just as a hint, what you're gonna have to do for that one, you can't use any of those identities that we wrote down right now at the moment. What you're gonna have to do is you're gonna have to FOIL out the first bracket and FOIL out the next bracket, the second one, and see what happens, right? Because sin x plus cos x squared is the same as sin x plus cos x times itself. Right? And then you can FOIL out. So you're gonna say sin x times sin x is sin squared x, okay? Outer is gonna be sin x times cos x is sin x cos x. Inner cos x times sin x again is sin x cos x. And cos times cos is cos squared. Alright, should I just do that? It's obviously not the whole thing, right? I'm just helping you with the first bracket. So sin times sin is sin squared x. This isn't a model solution, guys. I'm just showing you how to do the first bracket. You're going to have to do the next one as well. And remember, you must do your whole LHS thing, hey? And that's going to be plus dot 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 the same thing for the second bracket. When you do your output, you're going to say sin x times cos x, which is going to be plus sin x cos x plus your inners, which is again cos times sin, so you can again write sin x cos x. And then your last cos times cos is cos squared x. Plus the same thing for the next bracket. Hey, you're going to have to FOIL those two out as well. Now guys, what do we see here? Cos squared x plus cos squared x. 1. They don't have to be written next to each other, guys. They can be separate. It's two terms, right? Sin squared x plus cos squared x. Those two you can put together as one and turn it into one. Right? Because that's first identity. And what is sin x cos x plus sin x cos x? That's if you times them, hey? If you add it, 2 sin x cos x, yes. It's like what's x plus x? 2x, right? What's xy plus xy? 2xy. Okay, it's the same situation here. So I'm just going to write, remember sin squared x plus cos squared x is 1. So let me underline that in red as well. Plus sin x cos x plus sin x cos x is 2 sin x cos x. And then you would have a similar thing for the other bracket that was squared. Okay, I've just done the 1/2 for you, but it's going to follow the same kind of layout. Okay, I'm just going to write down for number 5. You guys might have to take a picture of this because it's almost time to, oh, there's still 7 minutes actually. As for this one, we didn't do an example now with fractions. But remember to add or subtract two fractions, what do you always have to make the same? Before you can actually, you have to make the denominator the same, right? So sin x is actually sin x over 1. So you need to make the denominators the same there. So what are you going to do? How to change 1 into sin x? Times by sin x, okay? What's 1 times sin x? That's just going to be sin x, okay? So here, you're going to have to times the denominator by sin x to make it the same as the other one. But then can I just do that at the bottom? No, I have to do it at the top as well. Right? Then you can put it together as one fraction just with one denominator of sin x. And then go from there. Okay, so for number 5, you need to make denom the same and write as one fraction. And the next one that I said was 3 was 9. So that's the next one. I'm just going to do the first step with you guys. It's a fraction, right? But it's already one fraction. We want it to just be cos x. So we're going to have to simplify it by a lot. So I'm just going to show you here. What do you see? What can we actually change on the left-hand side there? What identity can I use? Tan, right? Is what? Sin x over cos x. Okay, so that's what you're going to do at first, guys. Even if you don't know where it's going to lead to, that will get you a mark. So please, whenever you see tan, change it to sine over cos. So it's 1 plus sine x over cos x. I'm not sure if we worked with compound fractions earlier in the year. Does that term sound familiar? Compound fractions. So you have a fraction within a fraction, which is what we have here. Hey? I'm just going to write on the side. This is a compound fraction. So do you guys see what I mean? We have a sine x over cos x within the fraction. Okay, so it's a fraction within a fraction. So compound fraction, and guys, there's a very nice way of working with this, which is a little bit of a trick. What you're going to do is you're going to times the top and bottom, or numerator and denominator, I suppose is better terminology. But times the top and bottom by the denominator of the inner fraction. Everything at the top and everything at the bottom by that denominator. What is the denominator of the inner fraction? Cos x. So I'm going to times that sine x by cos x. I'm going to times that cos x by cos x. I'm going to times the 1 at the bottom by cos x. And then finally this inner fraction by cos x. So now what happens with that, with this here? The cos x's are going to cancel out. Alright, so that is the quickest way, guys, of getting rid of that inner fraction. Okay, but now all your other terms, right? We're going to have sin x cos x plus cos squared x over cos x plus sin x. Okay, see what you can do from there. And then number 12 is another fraction, guys, with a tan. So again, like I said, change tan and sine over cos. It's two separate fractions, make the denominators the same. Okay? Kind of like number 5. Just a bit more difficult, the next one, number 12. Guys, remember you're doing number 12 as well. I don't have time to write it down now, but it's in your book. Books.